About pushdowns, I think I will just show you a few examples. So there are many things that we push down. The idea is that the architecture of Yugabyte, we have this distributed storage, and on top of it, we have Postgres. If you are doing aggregates, if you are doing analytics, you don't want to retrieve all rows and then have the Postgres backend, a single process aggregating all that. So the idea of pushing down is that some SQL operations will be done on the storage itself. Let me create a sequence to see the difference. And I will mention cache 100. It is the default anyway, because we want to scale and a sequence just generates incrementing numbers. And of course, the last number is stored in a table in one place. You don't want to hit this table each time you want a new number. So there is a cache that is per session, or we have also done that per server. So basically, I'm using a cache, and I will show the difference with the sequence pushdown or not. First, let me show you the few parameters that contains push in it. So the parameters that start with YB are the Yugabyte one in addition to the Postgres one. And we have this enable sequence pushdown, and this is what I will show you. Let me just generate some numbers. So I select next val from my sequence for 50,000 to get 50,000 numbers. So basically, getting 15,000 numbers with a cache at 100 means that I will hit the sequence, update the sequence 500 times. And I will run that in loops every seconds. And now I will show you on the console. This is my cluster, my test cluster. If I go to cluster and nodes, we see some basic information, and the read and write operations are the operations sent from the SQL layer to the storage, reading and writing. So it's not each insert, because an insert can insert many rows and in a single operation. It's really the operations between those two layers. And basically here, you see 500 writes to one node. And that's exactly my sequence. The sequence sits only in one node. And this is with the optimization, just to show you how it was working before if I disable the optimization. So what happened before this optimization, if I run the same again with a watch, and if I refresh there, so this is what we had per second, 500 reads and then 500 writes. Because if there is no optimization between those two layers, updating a sequence is getting the value and then updating with a +1 on it. And this can be still fast if it's just a question of milliseconds because you are in the same region. But if you have a lot of activity, it's always easier to do single operations. So the push down is doing the read and the write in a single operation.